This is another set of triangle proofs. So let us try to get started here. The line segment DA bisects the angle BDF. Then BDF would have been this one. The fact that this one bisects that angle, that means angle 2 and angle 3 must be congruent to each other. Alright? Now angle 1 and angle 4 are also congruent. I use the dot to uh, mark that. And line segment CD, which is outside line segment, is also congruent to DE. Now we want to try to prove the triangle, in this case, CDA. CDA, that means we're looking at the outside upper big triangle right over here. That triangle is congruent to the one in the bottom. Now how would you be able to do this? In fact, when you look into this one, we have one condition, which is the side. And we have two parts of the angle. Then in fact, if you combine them together with the addition postulate, then we'll be able to get the second condition. How about the third condition? Oh, that's right. In fact, the line segment AD is common in both. There it goes. Hence, we have SAS congruence. So let us try to write up the proofs together. So I'm just going to draw the line here. All right, so let's get started. Here we have statement. And here we have the reasons. First, we're going to write down all this given right over here. Okay? And then first one, the reason will be the given. Now, second step. Since the DA bisects that, as we marked angle 23 is congruent, we will realize the angle number 2 must be congruent to angle number 3. What's the reasoning? That's right. An angle bisector divides an angle into two congruent parts. All right, so we got the first condition done. Number 3. But not only do these portions of the angles are congruent, because angle 1 and angle 4 are congruent, therefore we can say the angle CDA is congruent to angle EDA. As I mentioned with the blue mark right up here, we need to add up these two angles. So this will be number 3, addition postulate. All right, now let us move on to number 4. We also talked about line segment DA. It's congruent to line segment DA. Now step number 4, that's because of the reflexive property. Now number 5. Then I believe that we are ready to say these two triangles are congruent. Triangle CDA is congruent to triangle EDA. What's the reasoning? Side, angle, side. Same here, side, angle, side. There it goes. And that's our proof for number 1. Let us continue to move on to number 2. Here we have, I'm going to use the red once again, GA is equal to FE. Yes, to be more specific, we actually have to say they are equal, therefore they are congruent, but we're just going to, simplify them to be as a one step. And these, the midpoint of AE, then makes these two line segments to be also equal to each other. Now, GA is perpendicular to AE, that means they're right angle. So is the other side. Then how can we prove that these two triangles are congruent? By SAS. So once again, just like before, let us try to write up the proofs here. Statement. And then here regions. Number one, once again, we're going to put all these things right over here. And the reasoning will be the given. Number two. Then we realized because of D being the midpoint, we have realized that AD must be perpendicular to ED. And the reasoning behind that? Yes. A midpoint divides a line segment into two congruent parts. All right, so number three. After we have said that, we have to write, say angle GAD and angle FED. Those are right angles. Now, statement number three, because perpendicular lines form right angles. Now, statement number four. When because they're right angles, we get to realize that they are also congruent to each other. GAD must be congruent to angle FED. Number four, because all right angles are congruent. Now, statement number five. Once again, because of that reasoning, we get to realize that triangle DAG must be congruent to DEF. Reasoning? Yes. Once again, it would be SAS. SAS. You see the angle is between those two sides. All right, great. Let us move on to number three. Here we have BD is perpendicular to AC, which makes this angle to be congruent to this angle. Both of them are right angles. And AB is congruent to BC. All right, everything is very nice. Except that we need one more condition. Oh yeah, that's right. Between these two triangles, this line segment must be common. All right. And do you think we can prove that the triangle on the left side ABD is congruent to CBD? Yeah, yes, by HL, as you can see, hypotenuse, like hypotenuse, and like. All right, let's write up the proofs. So here we have statement, and here we have the reasons. First, we're going to write down the givens right over here. Number two, you see, because in this case, angle ADB and angle CDB are right angles. Number two, because perpendicular lines form right angles. Number three, because those are right angles, we get to realize that triangle ADB and triangle CDB are right triangles. You see, we need to state that those are right triangles because we'll be using the word hypotenuse here. So number three, triangles with right angles are right triangles. Of course, number four, SBD has to be perpendicular to BD. Step number four, why? Because of the reflexive property. Now, then we can say number five, here we have triangle ABD must be then congruent to triangle CBD. Why? Step number five would be the HL, hypotenuse line. All right, let us look at question number four here. All right, so let us look at number four. So angle BCE, meaning this outside angle, is congruent to DCE, which is the other outside angle. The line segment AC bisects the angle BAD, then makes this portion of the angle congruent to that portion of the angle. All right, how can we prove that upward triangle is congruent to the lower triangle? All right, let's reason a couple of things out together. Because these two exterior angles are equal to each other, this X marked angles will be also congruent to each other because they are supplementary to the congruent angles. Now, second thing, here the line segment AC is common in both triangles, once again by reflexive property. Therefore, we have angle, side angle. I guess that seems to be our reasoning. All right, so let us write down our proofs together. Statement and regions. First, we have this one writing way over here. Number one, it will be givens. Number two, angle ACB and angle ACD are supplementary to angle BCE and angle DCE. Now here, why are they supplementary? Because they're linear pairs. Meaning basically, two angles make up a straight line. That's what it means. Number three, because those happen to be the supplementary to congruent angles, we get to realize that angle, once again, ACB must be congruent to angle DCB. Why? Because supplementary to congruent angles are congruent. Now we have one more condition for us to talk about. The line segment AC. AC must be congruent to AC with a reflexive property. Number 5. Then we can say triangle ABC must be congruent to triangle ADC. Why? If you have to go back to the picture, we get to realize that it was angle, side angle. Angle, side angle, right there. That's how we can prove it. Great, so let us move on to the next question. Number 5. Here we have SM is the bisector of the angle L, a bisector of the line segment LP. That makes LM is congruent to MP. And RM is congruent to NQ. That's the second condition. And at the same time, angle A is congruent to angle B. All right. But angle A and angle B are not part of the triangles there which we want to prove them to be congruent. But you will realize, since it's a perpendicular, we have to realize that this is a right angle and that's a right angle. That means when two angles add up to a right angle, that means we call them complementary. Then you will realize that number 1 and number 2 should be equal to each other because their complementary angles are congruent. All right. Then let's try to write them up. Because then by SAS, we will realize that these two triangles must be congruent. So just like before, let's just write it up here together. Statements and regions. First, we're going to put down the givens way over here. Now, since SM is a bisector of LP, we get to realize that LM is congruent to PM. Because SM is a bisector, so we get to realize that a bisector divides a line segment into two congruent parts. Now, number 3, we have to also realize that angle LMS and angle PMS are right angles. Because number 3, we get to realize that perpendicular line form right angles. Now, after we've set up that these makes up the right angles, and step number 4, we can say angle LMS is congruent to angle PMS. Why? Because all right angles are congruent. Then we can say, since both right angles are congruent, but angle A and angle B are also congruent too, then by subtraction postulate, we will realize that angle 1 must be congruent to angle 2. And statement number 5, it could have been subtraction postulate. Now, after proving angle 1 and angle 2 are also congruent, then I think we are ready to write down the proof statement. Number 6. Triangle RLM must be congruent to triangle QPM. Why? It was SAS. If you look through them, it was SA, which is the angle between and S. Alright, let us move on to the next question here. Alright, so let us look at number 6 together. Here, AE, which is this line segment, is perpendicular to DB. So we have a right angle right over here, and so is another one right over here. And DE is this part of the line segment, is congruent to FB right over here. Then as you mark that, you will realize that the middle portion seems to be reflexive. Now DC is perpendicular to AB. Alright, then in order for you to prove these two triangles to be congruent, it looks like we might have to use the addition postulate. By adding these two line segments must be equal to adding these two corresponding parts. Alright, then we get to once again realize, because it's a right triangle, we get to have hypotenuse legs, just like earlier. Let's see what we can do here. So let us write down the statement. And then regions. Alright, first, we're going to write down all these givens right over here, and our regions being the given. Now, number 2. We have to realize the angle DFC and angle BEA are right angles. Now, statement number 2. Why? Because perpendicular lines form right angles. Number 3. And then, since those are right angles, we get to realize a triangle ABE and triangle CDF are right triangles. The reason is because triangles with right angles are right triangles, simply. Alright, statement number 4. We have to use the reflexive property once again, EF. It's congruent to EF by reflexive property. Number 5 here, it becomes, we need to add up those two, so we end up getting DF must be congruent to BE. Why? It will be addition postulate. Then I think we are all ready to say the last statement. Number 6, triangle ABE must be congruent to triangle CDF. Why? By the hypotenuse leg. Alright, so with this one, we have finished 6 questions. This will be the last question. Angle A is congruent to angle D, and line segment AE is congruent to CD. It looks very similar to the previous question, as you can see. This being reflexive, we get to realize that this side of the line segment must be equal to this side of line segment. And also another given is angle AEF, which is this outer angle, must be congruent to BCD, which is this outer angle. Alright, I think we have almost everything, so let us try to write them down. So first, here we have statements, and here we have regions. First, we would write all these givens right over here, and the reasoning would have been, of course, givens. Number two, yes, we have to realize that EC must be the reflexive congruent to another EC, the reasoning being reflexive. Now, step number three. So first condition, first pair of the angles were given. Now, second condition would be the pair of sides. But we don't have the third one, except that we only have the outer angles. If you think about it, if you realize the outer angles are congruent, then you get to realize that supplementary angles are also congruent to each other. And that's the route which we like to go for. So here we have angle ACB and angle DEF are supplementary to angle BCD and angle FEA. Number three reasoning, because it's linear pair. Meaning pair of angles that makes up a line, meaning supplementary. Number four. Then we can say angle ACB must be congruent to angle DEF. The reasoning would have been supplementary to congruent angles are congruent. That would be the reasoning. So I believe we have almost everything here. Then number five, we can say triangle ABC must be congruent to triangle DFE. And reasoning would have been angle, side angle. Angle, side angle. Alright, that's it. So that's it for now, and have a nice day. I'll see you guys later.